Good morning. I had told you I would give you a couple examples of the formula and how to do these word problems. So just really quickly, AF equals A at 1 plus or minus R is a decimal to the T. I know the formula said X, but T and X, it's totally fine. So example A, I'll run through a couple of these. I won't do them all. I'll do them all and post all the work, but I won't talk through all of them because I don't know that we need to listen to me talk for quite that long. You bought a car for $15,000. Its value depreciates. That means it's going down at a rate of 4% each year. How long will it take for it to be half its current value? Okay, so here we go. I'm going to copy down the formula because you know me, I always start by copying down the formula, but I'm going to tweak it a tiny bit. I am depreciating, well, my car is, and so I'm going to change it to, okay? So there's my formula. The initial value of my car was $15,000. It's depreciating at a rate of 4% as a decimal. Sorry, just had to throw it out there. And then I am wanting to know how long for T that it will be half. Well, half of 15,000 is 7,500. So here we go. I want to solve for T. This says use a graph. We are smarter, wiser, better looking than we were a couple days ago, and we know how to solve this. So I'm going to clean up my parentheses. And I am going to divide this 15,000 out of here. What I hope you realize is that since it's half the value, it's going to make a 0.5 on the other side. If not, grab your calculator. 0.5 equals 0.96 to the T. Cool. We had 4 strategies, 2 of them for exponentials. If I have exponentials on both sides, I can make common bases. That is not happening here. So I'm going to change it to a logarithm. Okay, the base stays the base. So log base 0.96, and then the other 2 flip their homes, right? The base stays the base. This is our base. Whoops. I want it green so it stands out. There's our base. These 2 flip. So now I go to my calculator. Dun, 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 and I've got log base 0.96 of 0.5. I love my Math Alpha math for this. If you do not have Math Alpha math, hang on for 1 second because we can also do our change of base formula where the base stays in the denominator. And either way, it's going to take me about 17 years for my car to be about half the value it was before. Okay, so that's a depreciation example. In this example, the value of my house is increasing, and so we would do the same thing, but we'll do increasing. I will work through that one, but I'm not going to record it. I'll just work through it and post the worked out example when I post this entire page. Let's do this Farhampton one. If you don't know Farhampton, if you have not seen How I Met Your Mother, totally fine. But the population is decreasing, which is kind of a bummer, but that's okay. At a rate of 3%, 0.03. And you guys are like, so shut up, we know. But I don't want you to make that mistake in a time like on your test or something. So that's why I'm hammering it into you. In 2000, there were 1,700 people. Find the population in 2012. There's a reason for going over this one. Decreasing means subtraction. I want to find, I probably could have used the P example, but we'll just go with what we've got here. I can still use A, it's just amount of people. My initial population was 1,700. I'm decreasing at 0.03. And now my T. It feels like we want to put 2012 as T because that's what the year is, but we need to be careful. From 2000 to 2012, that's actually 12 years. Shocker, right? So in that T spot, I'm going to put the 12 instead of the 2012 because I need to be able to interpret the problem and really know what it's asking. So I'm going to clean up my parentheses, and then I'm going to go to my calculator. So here we go, calculator. Calculate this. 1,700 times, we were decreasing at 3%, which means our value in our parentheses worked out to be 0.97 raised to the 12th. That looks like what we had in our example. So I'm going to push enter. And our population, now, we do not use half of a person. So instead, we're just going to say, I'm going to round this up. I'm going to say 1,180. If you round it down, I would forgive you on a test. There'd be enough of a buffer where you'd be okay. So example C is a population where it's decreasing. Example D is another population one. This is increasing. Let's run through this one real quick. So the humpback whale population was 350 in 1981, has increased at a rate of about 14% each year since then. When will it reach 20,000? Here we go. This is an increasing one. It's kind of fun. We are excited that there are more whales in the world. I think that's probably a really good thing. I don't know. I think whales are cool. They're kind of scary in the sense that they're huge. I don't know if I'd want to meet one face to face, but the fact to know that they're out there, they're just kind of these cool creatures. I don't know why I got off on that tangent because here we go. We want to know when the final number of whales is 20,000 whales. That's a lot of whales. I'm sure they're not all in the same place. Initial is 350 whales. 1 plus R. They are increasing by 0.14%. And we need to solve for T. So let's clean up those parentheses. Some of you probably can just write 1.14 get-go, in which case, more power to you. But I am showing you all the steps because I feel like that's part of what I have to do. Here we go. Solving. Speaking of showing all the steps, 350. Dividing off some of those whales to know just how much it's increased by. So 20,000 divided by 350 is going to take my calculator. 20,000 divided by 350, 57.143 equals 1.14 to the T. Okay. You can hopefully avoid rounding if you track stuff in your calculator, but if you end up rounding early, that's fine. Just try and keep lots of decimal places. It's just good practice to hold as many decimals as you can for as long as you can. This is a great opportunity to use the definition of a logarithm to change it into a logarithm. So here we go. Calculator. First of all, there's the 20,000. I did it on my phone calculator, but here it is. If I want to trap that number, sometimes it's kind of nice. And now I need to do log with a different base. So I'm going to go math, alpha, math. And my log, the base was the 1.14, right? Because that was the base of the original exponent that we wrote, which means it's also the base of our logarithm. In here, I'm going to, like I said, if you can avoid rounding, that's going to make your life a little easier, and it's going to make your answer more accurate than it would be if you started rounding part of the way through. So I use second and then the negative symbol to pull that 57 and change into my parentheses to do my log math alpha math. So it's going to take about 30 years, 30.87 years. We can use decimals. Remember, people, we don't use decimals. That would just be sad. But for years, we totally can. So 30.88 years. So T equals 30.88 years. Since this question is asking when, we might want to really be careful and say, hey, 1981 plus those 30.88 years will take us to, what would that be? 2011.88, so 2011 to 2012, somewhere in there. So yay, whales. I wish I could draw a whale. I feel like that would make this example like 35,000 times better. But I'll practice and get better for the next time we talk about whales. So that's using that AF formula. We had one more variation on that AF formula, and it was about half-life. So here's a half-life question. The half-life of chromium is 28 days, 4 weeks. The original sample contained 510 grams of chromium. How much would remain after 1 year? Now, immediately, your brain should be going, ding, ah! Not because you don't understand the problem, but because you're going, days, year, okay. Well, we need to just be mindful of that and say, you know what? 1 year, 365 days. Now we're good. Now we can use this formula because now we know what is happening here. So half-life formula, the final amount, the initial amount, half-life, T over H. Initial amount, 510 grams. The time frame is 365 days. The half-life is 28 days. We talk about this. The reason we divide it is to figure out how many half-lives have happened. Because every time one happens, we've cut our value in half. Okay? This is a great opportunity to use your calculator because, let's face it, we are not about to do this in our brain. I think that would be not fun for anyone. So here we go. 510. 0.5 because it's a half-life problem. And then you know what? Let's just, again, we're trying to avoid rounding. Let's let our calculator do as much as possible here. Now, there's times and places where we can do that. In this one, everything fits nicely. We're not doing stuff to each side of the equation. We're just doing it. So here we go. We are going to click enter, and we are going to see that we've got about 0.06 of a gram. I'm going to say 0.061 grams. Not much left. 0.061 grams. I think that would be 61 milligrams. If I'm thinking correctly, very possible I'm not. But either way, 0.061 grams. One more half-life question. I know we went through a lot of these. I said I wasn't going to do all of them. I only skipped one, so we basically did all of them. But hopefully you're picking and choosing and seeing which ones you want. So half-life of radium is a lot of years, 1,602 years. If you have 500 grams present today, how many would have been present a lot of years ago? Crazy question, kind of awesome. Stay tuned. AF equals A initial, half. I have a fraction in the original formula, but we're smart people. We kind of know what's going on. T over H. AF, the final amount right now, today, chilling at your house or in some science lab somewhere, there are 500 grams. The initial amount is what we're supposed to be finding here. It's been cut in half over the course of 9,612 years at a half-life of 1,602 years. So this is a weird question. It's a little bit different, but it's kind of awesome, and I'm super excited to finish it with you. 500 equals A initial. Okay, so here we go, 0.5. This 9612 divided by our 1602 tells us we've gone through 6 half-life cycles. So we've got 0.5 raised to the 6th. Whatever that is going to probably be a teeny tiny decimal. So I'm going to take that 0.5 to the 6th, and I'm going to divide 500 by it. If we're going back in, this is going to sound weird. If we're going back in time in terms of half-life, we will be gaining. We should have more radium in our answer than we do right now with the 500. So it was cut 6 times, so I'm going to divide it by 0.5 to the 6th. And that's going to tell me 32,000 grams of radium. 32,000 was our initial. Okay. So that was kind of a weird one, but it was nice to see. Hopefully you at least watched a couple of these, even if you didn't watch all of them, that's fine. If you wrote something down, great. If you chose not to write something down, still great. This was kind of meant to just give you some ideas. Hopefully they helped. Hopefully feel a little bit better about word problems and exponentials and all the things that come along with it.